All right, here we go. This is problem number 1 from Chapter 6 of Holiday Resnick. We've got this railroad car. It says the floor of the railroad flat car is loaded with loose crates having a coefficient of static friction of 0.25 between the floor and the crates. The train is initially moving at 48 kilometers an hour. So obviously you need to convert that to meters per second. And then the question is, in how short of a distance can the train be stopped at a constant acceleration without causing the crates to slide over the floor? So the idea is that these are the crates sitting on the floor. As the train slows down, the thing that's going to be stopping the crates is going to be your force of static friction, right? And so the amount of static friction that we can use is up to whatever the max is, right? So the issue here is that we're not given the mass, right? So here's what we know. We know that the crate has a mass m. That means that your force of gravity is just going to be mg. That means your normal force, since it's just sitting on a flat railroad track, is also going to be mg. And therefore, our force of friction static maximum is going to be equal to our coefficient of static friction times our normal force, which for us is 0.25 times mg, right? So the idea then is that as the train slows down, it's going to be accelerating. This is going to be our net force, right? That's, well, the maximum net force, I guess, that we've got, right? And so that means that the maximum acceleration that we can have would be the net force divided by the mass, which for us is 0.25 mg divided by the mass gives you 0.25 g, which is, what, 2.45 meters a second squared. And this is going to be negative, right, because we're decelerating. Okay. So now the question is, what is the question? The question is, how short of a distance can we stop in, right? So let's do this. So the next thing we got to do is do this. So we know that our initial velocity was 13.3 meters a second. We're trying to stop the train, so it's final velocity of 0. Oh, sorry, I'm trying to switch to new notation. Let's see, initial velocity, and at the time when the velocity is 0, the question is, what's our displacement going to be? Oops, that's a delta x. If our acceleration is negative 2.45 meters a second squared. So to solve this guy, you just use this guy, 2a delta x equals v squared minus vo squared. Plug in your numbers and solve for your displacement, and you end up getting 36 meters. There you go. I feel like I haven't said enough here. I guess the important thing to understand here is that our goal is to prevent the crate from sliding, right? And so static friction is what's going to allow that to happen, right? If the train stops too quickly, there won't be enough static friction to slow the crate's forward velocity. Okay.